and I let me start with some informal introduction. Uh, हर एक स्टूडेंट जो है वो नाम तो मेरे पास हैं ही यहाँ पे, so kindly tell the place from where you belong, कहाँ से कहाँ के रहने वाले हैं. So let me start one by one. The first one it is Rishi Dhiman.
Yes, sir. Sir,
Dhiman
yes,
कहाँ से रहने
sir.
वाले हैं?
Sir, I am from Ambala Kent.
Okay, you are from Ambala Kent. Good. Next is Mr. Ritvik Gupta.
Good afternoon, sir. I'm from Lucknow.
आप प्रॉपर लखनऊ से हैं?
Yes, sir.
ओके. शुभम मौर्य.
Sir, Varanasi, UP.
वाराणसी.
Yes.
बनारस से. ओके, गुड. मिस्टर नेक्स्ट इज मिस्टर प्रतीक. प्रतीक इज ऑनलाइन? नो. प्रतीक का कोई रोल नंबर भी नहीं है. ये हमारे स्टूडेंट है या नहीं? प्रतीक. ओके. रोल नंबर 58 मिस्टर प्रियंका घोष.
सर कोलकाता से.
कोलकाता से. गुड. प्रॉपर कोलकाता से. ओके. देन नेक्स्ट मिस्टर राहुल, रोल नंबर 61.
Good afternoon, sir. Sir, I am from Narnaul, Haryana.
नारनौल हरियाणा. ओके. देन मिस्टर राज, रोल नंबर 63.
Yes, sir. I am from Gaya, Bihar.
गया बिहार से. ओके. देन वी हैव द नेक्स्ट रोल नंबर मिस्टर रजनीश जैन.
सर
65.
सोलन हिमाचल प्रदेश.
सोलन हिमाचल प्रदेश. गुड. नेक्स्ट वी विल हैव द मिस्टर रवि कुमार, रोल नंबर 66.
Yes, sir. I am from Patna, Bihar, sir.
पटना. ओके. देन वी हैव द रोल नंबर 67 मिस्टर रवि कुमार विमल.
Yes, sir. I am from Chandigarh.
चंडीगढ़ कहाँ से?
Sir, 46.
कहाँ से? रिपीट once
Sector
again.
46.
Sector 46. Good. Then we will have next is Mr. Ravi Kumar Bimal, roll number 67.
Yes, sir.
आप ही थे कि?
हाँ जी सर.
Okay. Then we have roll number 71, Mr. Sachin Kumar. Etawah, Uttar Pradesh. Good. Then next we will have roll number 72, Mr. Saksam.
I am from him.
Yes, Saksam, speak loudly.
Sir, I am from Himachal Pradesh, Unna.
From which place?
Sir, Unna, Himachal Pradesh.
District Una.
Sir.
Okay. Then we have roll number 70. We have roll number 75. Roll number 75.
Good afternoon, sir. I am from Kolkata, West Bengal.
Kolkata. Okay. Then we have roll number 77, Mr. Sivan Singh.
Good afternoon, sir. I am from Ludhiana, Punjab.
Ludhiana, Punjab. Good. Roll number 81, Mr. Subham.
Yes, sir. I am from Ghaziabad, Uttar Pradesh.
Ghaziabad, Uttar Pradesh. Okay. Then we will have next is Mr. Someone joined recently, I think. Roll number 82 हो गया?
No, sir. 82
Okay.
नहीं हुआ. Sir, I am
81.
from Jharkhand.
Jharkhand.
Yes, sir.
Okay. Then we have roll number 83.
Yes, sir, I am from Hamirpur, Himachal Pradesh.
Hamirpur, Himachal Pradesh. 1 minute, please. हेलो. हाँ जी अशोक जी.
सॉरी डिस्टर्ब कर दिया. मैं 2-3 मिनट, आधा मिनट लूंगा सर.
हाँ
बिजी तो सर क्लास में.
क्लास ही है.
अच्छा,
मैं करूँ क्लास? बोलो. मैं क्लास की बात करूं?
नहीं कोई बात नहीं, बस मैं तो ये पूछा था, वो मिनी था आपके पास, सुमिता था, एक्चुअली मेरा 2 सबमिट हुई थी।
अच्छा, मैं आपको बताता हूँ सर, है ना, एक बार देख के ना। ठीक
कोई इशू नहीं, बाद में
ठीक,
कर
मैं
लेंगे
करता हूँ,
सॉरी
नो नो प्रॉब्लम। सो आई थिंक कहाँ तक पहुंच गए थे? रोल नंबर 82 तक 83 हो गया था।
Yes, sir.
ओके ओके, मिस्टर रोल नंबर 84 तनिष रैना,
Good afternoon, sir.
Good.
I'm from Chandigarh.
चंडीगढ़। कहाँ से?
49th.
49, ओके। देन वी हैव रोल नंबर 86 मिस्टर तुषार कुमार।
Good afternoon, sir. I'm from Mohali, Sector 79.
Okay, sector 79. Then we will have next 87 Basudha.
Good afternoon, sir. I'm from Himachal,
afternoon.
Shamirpur.
District Hamirpur. Okay. Next we will have Bisal Ras, roll number 92,
Sir, I am from South Delhi.
South Delhi. Okay. Next we will have roll number 94, Aditya Kaushik.
Good afternoon, sir.
Good afternoon.
I'm from Derabasi district, Mohali, Punjab.
Derabasi. Okay, adjoining Punjab, Chandigarh. Huh? Okay,
Yes,
next is roll number 95, Anmol.
Yes, sir. Sir, I am from Mohali, Sector 63.
Sector 63. Roll
Yes,
number 97. Inka.
Sir, I'm from Chandigarh.
From which sector?
Sir, Sector 50.
Sector 50. Good. Then we will have roll number 99. Mrs. Karan.
Sir, good afternoon, sir. Sir, I'm from Chandigarh.
Chandigarh. From which sector?
Sector 13.
Sector
Sector 13.
13.
Yes, sir.
Okay. Then we will have next is 101, Mr. Kartik Sharma. Kartik.
गुड आफ्टरनून सर। सर मैं कोटा राजस्थान से हूँ सर।
कोटा राजस्थान से। ओके, 103, 102, Nilesh Singh.
Good afternoon, sir. Sir, I am from Kolaba, Mumbai.
From Mumbai. Okay. Roll number 104.
Good afternoon, sir.
Good afternoon.
Sir, I am from Chandigarh, Sector 49.
Sector 49. Very good. So I think the number of students in your class, there are 40 or 45?
47.
As a total number of students, there are 47. Okay. So how is your life? All is well?
So it's as good as what we do in an online environment.
नो सर।
So what you wanted, ki classes should be held offline?
Yes,
Yes,
sir. We
sir,
would love
offline,
if the
sir.
classes would be like held online.
Okay, so I think very soon, second year students, they may be called. अभी तो final year को call हुआ है, तो I think within by March beginning, you may be called offline. So I think very soon you will be called on campus. So let us hope. So who taught you in third semester? So Dr. Jyoti Sharma. Okay. So have you enjoyed mathematics? कुछ लर्न किया आप
Yes,
लोगों
yes.
ने या इट इज? हाँ बोलिए। Yes. Have you enjoyed mathematics 3, linear algebra and complex analysis or not?
Sir, we were taught in a very categorical manner, so we did like the subject to a certain extent.
In categorical manners means what?
Sir, I think she taught us in a really like elaborate way, so it was
Okay.
very easy to comprehend what she taught.
Okay, okay. So you enjoy which topic more? Linear algebra or complex analysis?
So linear algebra was on the easier side, so it was like.
Okay, but linear algebra is concept wise it is easier as compared to complex analysis. Is it?
Sir, to me, yes.
Okay. Rest of the students, कौन ज़्यादा easier लगा? Linear algebra. So, if I look from the perspective of mechanical engineering, so which is more relevant to mechanical engineering?
Sir, linear algebra.
Linear algebra. How?
Sir, because we don't really use complex numbers in real life, I think.
Ritvi Gupta is saying that linear algebra has more applications in mechanical engineering as compared to complex analysis.
Yes, sir.
So, are you agree with his statement? Anyone else? But do you think linear algebra has this type of applications?
Sir, vectors, matrices.
Linear algebra की अगर मैं practical applications देखूं, so what do you think कि क्या applications होंगी? Anyone? कोई एप्लीकेशन आप लोगों ने देखा होगा, सब्जेक्ट पढ़े कहीं ना कहीं यहाँ पे दिस linear algebra का कोई concept यहाँ पे कि we can have practical applications in this field, कहीं deliberate किया, कोई चीज सोची?
सर अप्रोक्सीमेशन में
बोलिए।
यूज होता होगा।
हाँ।
सर
Yes.
अप्रोक्सीमेशन में सर टेलर सीरीज वगैरह।
टेलर सीरीज तो linear algebra में नहीं आई ना।
सर अप्रोक्सीमेशन में यूज नहीं होगा लीस्ट स्क्वायर वगैरह।
आप लोग सारा कोई linear algebra में क्या लगा आपको, क्या चीज थी कि कहाँ एप्लीकेशन हो सकती है? Have you ever thought? या कहीं पे भी आपको लगा कि सर यहाँ पे हमारे काम आ सकती है, आप कोई भी चीज पढ़ते हैं तो हाँ बोलिए, कहीं पे भी कोई एनी फील्ड। तो आप कह रहे हैं कि लीनियर अलजेब्रा अगर मेरे पास बिग डाटा एनालिसिस हो या आर्टिफिशियल इंटेलिजेंस हो, या सेकेंडली जैसे आप लोगों के पास अगर मैं गूगल सर्च इंजन है, इफ आई ट्राई टू सर्च any topic, so I got page 1 means the page 1 will be given rank 1 having the most information, means most relevant information, then I will have the second side, third side. So all these concepts, they are based upon the concept of linear algebra. Linear algebra जहाँ पे भी आपके पास data analytics होगा, artificial intelligence होंगे, so basically they are the tools for searching out or for developing the algorithms to, जैसे मैंने कहा कि अगर आप लैरी पेज जो था, ही इज अ गूगल फाउंडर, तो लैरी पेज में जो पेजेस की रैंकिंग है, दैट इज बेस्ड अपॉन द कांसेप्ट ऑफ अ रैंक, तो द whole of the algorithm is based upon the combination of linear algebra and statistics. तो बहुत सारी एप्लीकेशंस हैं। अगर मैं कंप्यूटर ग्राफिक्स की बात करूं, या मेरे पास कहीं पे भी आप लोगों ने यहाँ पे linear algebra में स्टेट में सिस्टम ऑफ लीनियर इक्वेशंस कैसे सॉल्व करना है, तो इफ वी हैव अ प्रॉब्लम रिलेटेड टू नेटवर्किंग, whether we have a electrical networking or computer networking, if we model it, then the corresponding problems, they are governed by means of a system of linear equations. Is it? कम्प्लेक्स का कहां पे लगा आपको, कम्प्लेक्स में कहां कोई प्रैक्टिकल एप्लीकेशन हो सकती है? यस, कम्प्लेक्स एनालिसिस पढ़ा आप लोगों को, लगा कहीं फ्लूइड में कोई एप्लीकेशंस होंगी? एनीवन? एनीवन कोई कॉम्प्लेक्स की एप्लीकेशन फ्लूइड मतलब मैकेनिकल इंजीनियरिंग में कहीं ये एस्पेक्ट हमें हेल्पफुल होगा टू बिल्ड अप द कंसेप्ट्स? कोई भी किसी कहीं कोई एप्लीकेशन नहीं दिखी? यस. So if I look at the applications of complex analysis, so complex analysis is more relevant to mechanical engineering as compared to other branches. आगे चल के अब fluid mechanics, computational fluid mechanics, etc. These subjects, most of the problems they are solved by means of a complex analysis. For example, you have read analytic functions. Then you have read the concept of harmonic functions. So harmonic functions, they are nothing but they are the solutions of a Laplace equations. So Laplace equations, etc. means आगे चल के आप बहुत streamlines, etc. So many of the concepts, they are very much related with the concepts of a complex analysis. So what I wanted to say, you have read mathematics from +1, +2, then in first semester, second semester, third semester. But you have read, for example, in +1 and +2, you have read the concepts ki how to solve the polynomial equations, for example, how to solve a quadratic equation. Then the idea it can be extended for solving cubic equations, quadratic equations, and so on. Then you have read the concept of limit, continuity, differentiability, and integration. Then you go on studying, you have read the other concepts also, probability, statistics, etc., coordinate geometry, and so on. Then in first semester, again, you have read the same concept, but now for a function of 2 variable, 3 variable, that is concept of limit, continuity, differentiability. Then you have read many more topics related to Laplace transformation, Fourier series, etc., the linear algebra, complex analysis. Have you ever thought whatever you have read from +1 onward till date, these methods, have you ever found they have some limitations? आपने अभी तक जो +1 से लेके आज तक चीजें पढ़ी, you have read different concepts related to different mathematical concepts. So do you think they have some limitations? Yes. So, but I wanted to motivate you. We will study here the different branch of mathematics that is called numerical analysis. So why we need to study numerical analysis, or what are the motive and objective for the study of numerical analysis? इसको पढ़ने की जरूरत क्यों पड़ी? So I wanted to know, have you ever found that there is some limitations in the existing method so far you have read? कोई आपको limitation लगी? Yes, anyone else, please? Let me throw the problem in another way. Suppose whenever we do any numerical experiment, so generally we will deal with the numerical data or with the numerical computation. जब भी मैं कोई experiment करता हूँ, it can be an experiment of any experiment of physics, or it can be the experiment of mechanical engineering. For example, it may be related to the theory of machines, it can be related to the heat and mass flux, etc. So if we do any experiment, then definitely we will deal with the data or numerical data. So if we have the numerical data, if I wanted to find out the rate of change of one variable with respect to another, means I am interested to find out the first derivative or the second derivative, for the corresponding numerical data, the corresponding function, this is not given to me explicitly. मेरे पास खाली डाटा दिया है, आई एम इंटरेस्टेड टू फाइंड आउट और आई एम इंटरेस्टेड टू फाइंड आउट द फर्स्ट डेरिवेटिव और सेकंड डेरिवेटिव। फंक्शन मुझे एक्सप्लिसिटली नहीं दिया गया है। So do you think it is possible to compute the first derivative or second derivative if we are only provided with the numerical data? क्या ऐसा possible हो सकता है? Yes, anyone else please? But this is possible only if you are given a very smaller data. If data is very, very large, consisting of thousands of entry, then this assumption will not work. Isn't it? Secondly, you have read in integration, in the integration you have read how to compute or how to evaluate the definite integral. So geometrically, these definite integrals, they represent the area under the curves. So you have seen definite integrals, they have a number of applications related to how to find out the volumes and many other problems. You have read in case of a vector calculus, they are very much related to that is how to compute the flux, then how to compute the divergence, how to compute the curl, which are very much related with the mechanical engineering. So again, if you are given, so I mean to say, you have read the concept of integration in +1 and +2. So again, they have the drawback only very few standard definite type of integrals they can be computed by the existing methods. आप लोगों ने वहां पे पढ़ा होगा कि इंटीग्रल इस टाइप का है, then only then they are means we can compute them by the existing available techniques. If they are not of the standard type, then it is not possible to compute the corresponding definite integrals. Similarly, you have read how to solve a quadratic equation. Sometimes means we know if we are given a quadratic equation that will be nonlinear in nature. So we have a very easy formula if the standard equation is of the type ax square plus bx plus c is equal to 0. If we plot it graphically, then it will represent a parabola in the plane. So definitely it will have two roots. We have a very simple formula x is equal to minus b plus minus under root b square minus 4ac divided by 2a. So we can compute the roots for the corresponding equation. But if instead of a quadratic polynomial, if we have a cubic polynomial, if we have a biquadratic polynomial, then question arises, does there exist method by which we can compute the roots of a cubic polynomial or quadratic polynomial? So see, analytical methods, they exist for solving or for finding the roots of a cubic polynomial equation, biquadratic equations. But these methods, they are named as Cardan's method, Ferrari's method, but they are so lengthy and time consuming. It is almost useless to solve even a cubic polynomial or biquadratic polynomial by means of the analytical methods. क्यूबिक पोलिनोमियल और बाइक्वाड्रेटिक पोलिनोमियल को हम जो आप लोगों ने मेथड जो पढ़े इनको हम कहते हैं एनालिटिकल मेथड्स और क्लोज दे विल गिव द सॉल्यूशन इन क्लोज फॉर्म. क्लोज फॉर्म का मतलब सॉल्यूशन विल बी इन टर्म्स ऑफ द नोन एलिमेंट्री फंक्शंस. आपके एलिमेंट्री फंक्शंस कौन से हैं? एक्सपोनेंशियल फंक्शंस, लॉगरिथमिक फंक्शंस, ट्रिग्नोमेट्रिक फंक्शंस, इनवर्स ट्रिग्नोमेट्रिक फंक्शंस. All these functions, they are known as the elementary functions, means hyperbolic functions, they are also included. If we do not have the solution in terms of these elementary functions, then we call that the corresponding solution, it is not in terms of a closed form solutions. Similarly, if we go for the case of our differential equations, we can have a problem of ordinary differential equations. We can have a problem of partial differential equations. Again, you have read, if I took the simplest case, if we have a differential equation of first order, first degree, or first order differential equations, then you have read they are solvable only if they are variable separable, they are homogeneous differential equations, or they are equations reducible to homogeneous form. Then you have read they can be solvable if they are of the Leibniz linear type equations. They are solvable if they are the exact differential equations. If we are given any differential equation of first order, if the corresponding equation if it is not of standard form, then it is not possible to solve the corresponding equations by means of the existing methods so far you have read. Similarly, as I have said, whenever we are given the numerical data, if I am required to find out the derivative, or if I am required to find out the corresponding differential equations, both numerical data is given to us, that the method so far you have read, it is not possible to tackle such type of problems by means of the method so far you have read. मेरे पास जैसे आप लोगों ने कहा कि if you look at the different very dynamic literature related to meteorology, जैसे for example if I took the weather forecasting, so weather forecasting, it is totally based upon the concept of a numerical analysis. What we do, we will calculate the different parameter or input parameters. They can be temperature, they can be density, they can be pressure, etc. So we will have the different input parameter. So with the help of these different input parameters, we will try to find out what will be the next, means what will be the weather in the next day or in the next month or etc. So all these weather predictions, they are based upon the concept of numerical analysis. Parallelly, we will study many more. If we are given, means if we have the missile, if I wanted to hit any enemy aeroplane by means of a missile, so definitely we will have the input parameters. How it can be done? Again, you will see these all type of problems, they can be tackled by means of the method we will study here, that is called the numerical methods or numerical analysis. Similarly, I can take many other examples. For example, we may have the problems of population dynamics. We have a census after 10 years. So we have a data कि हमारी population 1950 में कितनी थी, 1960 में कितनी थी. So what we do, we keep on recording. So in order to predict the future population of India or all over the globe, या 50 साल के बाद कितनी होगी, after 100 years, what will be the population of India? Again, this can be tackled with the help of the method we will study here. In numerical analysis, the corresponding topic, this is called interpolation theory. So what I wanted to say, we will study here again the same problems. Problem कौन थी? जो +1 +2 में you have read कि how to compute the roots of non-linear equations. Again, we will study here all these problems, but with a different approach. हम वही चीज करेंगे, but with a different approach. Why it is required? As I have said, in linear algebra, you have read how to compute the eigenvalues and eigenvectors of a isosceles square matrices. So you have seen कि मेरे पास, if I am given a 10 by 10 matrix, if I am interested to compute its eigenvalue and eigenvector, so analytically this is not possible. आप लोगों ने पढ़ा eigenvalue, eigenvector?
Yes sir.
तो कहीं इसकी एप्लीकेशन लगी आपको? कौन बताएगा? आइगन वैल्यू से क्या समझे आप? यस, कोई भी बोलिए. प्रियंका घोष, प्रियंका घोष इज ऑनलाइन? नो. कौन बताएगा? आइगन वैल्यू पढ़ा आप लोगों ने? कौन
बताएगा? तो उसका एप्लीकेशन का आइडिया नहीं है.
आइगन वैल्यू से क्या समझिए आप? यस, कौन बताएगा भाई? कोई तो बताए. आइगन वैल्यू का मतलब है, कोई किसी को एनीवन आप लोगों ने कहीं ट्राई नहीं किया समझने की चीजें? हर एक मैथमेटिक्स की ब्यूटी क्या है कि ईच एंड एवरी टर्म इट हैज अ फिजिकल इंटरप्रिटेशन. Actually, what is eigenvalue? So you have read in linear algebra, whenever you are given a matrix, then the matrix will be associated with some system of linear equations. Or I can say कि matrices, they are nothing but they are the linear transformations. मैं linear transformation कहूँ, matrix कहूँ, आप लोगों ने पढ़ा कि corresponding to every matrix there will be a linear transformation and vice versa. तो eigenvalues क्या हैं? Eigenvalue, दिस इज अ मैथमेटिकल पैरामीटर. एक ऐसा पैरामीटर है, जैसे आप दुकान पे जाते हैं, इफ यू गो एट अ शॉप, मान लीजिए आप कपड़ा खरीदना चाहते हैं या यू वांटेड टू बाई राइस. आप कहीं दुकान पे जाते हैं, आप कोई भी चीज मान लीजिए चावल खरीदना चाहते हैं. सो यू हैव सीन कि इफ आई वांटेड टू बाई राइस, देन वी विल हैव द डिफरेंट क्वालिटीज. वहां पे चावल जो होंगे दुकानदार के पास बहुत डिफरेंट वैरायटी होगी. सम क्वालिटी में कॉस्ट अप्रोक्सीमेटली 50 रुपीज पर केजी, सम में कॉस्ट 80 रुपीज. Isn't it? So better the quality, more will be the price. So eigenvalue, this is the self value. मैंने कहा कि मिस आइगन वैल्यू किसकी? लीनियर ट्रांसफॉर्मेशन की. This is a mathematical parameter by which you can check the quality of any physical system. आपके पास कोई भी फिजिकल सिस्टम है. अब इलेक्ट्रिकल इंजीनियरिंग में फिजिकल सिस्टम क्या हो सकता है? यस, इलेक्ट्रिकल इंजीनियरिंग में कोई भी फिजिकल सिस्टम क्या हो सकता है? मींस इफ आई टुक अ प्रॉब्लम ऑफ बीम की प्रॉब्लम पढ़ी आप लोगों ने? इफ आई थिंक ओवर द प्रॉब्लम ऑफ बीम, तो बीम का काम क्या है? यस,
स्ट्रक्चर्स बनाने में यूज होती है.
हम बोलिए ऋत्विक गुप्ता, what is the function of beam?
सर इट इज यूज्ड इन मेकिंग
जोर से आवाज नहीं आ रही.
सर अभी आवाज आ रही है क्या?
हाँ, अब आवाज आ रही.
सर वो कंस्ट्रक्शन में स्ट्रक्चर्स वगैरह बनाने के लिए यूज होती है.
कंस्ट्रक्शन में स्ट्रक्चर का, अब बीम आपके पास एक प्रॉब्लम है, उसके ऊपर वो मतलब आई मीन टू से द बेसिक मोटिव ऑफ बीम इज टू बियर द लोड, टू बियर द वेट.
यस,
isn't it?
हाँ सर.
So basically if I wanted to check whether this beam is of any quality, कि means मेरे पास ये वेट उठा लेगा या नहीं, if I model this problem, then the problem it will be governed by means of a system of linear equations. So what I do, I will try to find out its eigenvalue and eigenvectors. So whenever we have, so I mean to say what will happen, a resultant problem it can be converted into the problem of the type ax is equal to b. अब मेरे पास यहाँ जो मैट्रिक्स A आएगी, it will give us the associated eigenvalues and eigenvector. So we will have the different possibilities. One eigenvalue it can be smallest, other can be largest. Some of them they may be intermediate. But from practical point of view, those eigenvalues which are either smallest in magnitude or largest in magnitude, they are of more practical relevance as compared to the intermediate eigenvalues. जैसे मान लीजिए मेरे पास 10 by 10 की मैट्रिक्स आ गई, तो मुझे पता है उसकी 10 आइगन वैल्यूज होंगी. ऐसा हो सकता है कि एक सबसे छोटी हो, एक सबसे बड़ी हो, या दो छोटी हो, दो बड़ी हो, बाकी बीच की होंगी. आई कैन हैव ए प्रॉब्लम ऑफ एलसीआर सर्किट. अगर मैं सर्किट को मींस इफ वी आर हैविंग अ प्रॉब्लम ऑफ एलसीआर सर्किट, मैं सर्किट में कितना मैक्सिमम करंट फ्लो कर दूं कि सर्किट डैमेज ना हो. इफ आई मॉडल इट, then again it will be governed by means of a eigenvalue problem of matrices. What will happen? I can check the quality. So I can say eigenvalue, this is a mathematical parameter by which we can check the quality of any physical system. So again you have read in order to find out the eigenvalue and eigenvector, if you have a smaller system, then it is very easy to find out the eigenvalue and eigenvector just by analytical methods. But if we have a 100 by 100 matrix or 1000 by 1000 matrix, then finding the eigenvalues and eigenvector, this is almost impossible by the method so far you have read up to the third semester. So here, so far you have read the problems or the methods or the techniques. All these methods, they are called the analytical methods. These methods, they will always provide you the 100% accurate answer. But these methods, they have the limitation at the same time. They are applicable only to a very few problems. They are applicable only to 5 to 10% problems. The rest of the problems, they cannot be tackled by means of the method so far you have read. So this limitation, it has led for the development of a more powerful techniques. The corresponding techniques, they are called computational techniques, or the topic is called numerical analysis or numerical methods. So these methods, they are different from the analytical methods. लेकिन इनकी जो theory है, जो essence है, जो perception है, more or less, they will provide the same answer. So here these methods, they are also known as approximate methods. So the idea is, what we do, we will study again the same problem. सारे के सारे हमारे वही टॉपिक रहेंगे जो आप लोगों ने पहले पढ़ा. हमारा पहला टॉपिक जो होगा कि हाउ टू सॉल्व द नॉन इक्वेशंस बाय न्यूमेरिकल मेथड्स और बाय अप्रोक्सीमेट मेथड्स, then how to compute or how to solve the system of simultaneous linear equations.